Now let's talk about carbohydrates. Carbohydrates, also known as sugars. Okay? So this includes sugars or polymers or chains of sugars. So not just one ring, because these are all rings, but they could be chains of rings. And the molecular formula of the simplest sugars is multiples of this formula. So it could be carbon 6, H12, oxygen 6. You see? They're multiples of that. And you have long chains of these rings, then we just multiply. And I'll show you. These carbohydrates or sugars contain a ketose and an aldose. Well, they contain a carbonyl group, a ketone or an aldehyde. Those functional groups that you need to memorize, right? If it includes a ketone, we call it a ketose. If it has an aldehyde in it, it's called an aldose. Okay? Again, if it ends with OSE, it's a sugar. These sugars are usually drawn in linear format to speed up time, but we also have this ring format when it's in an aqueous solution, when it's in water. So what do these look like? Okay. These are aldoses over here, and these are ketoses. Again, I'm not going to ask you to draw these out. I'll have one on the test, or a few of them on the test. You've got to recognize what these are, okay? I might circle areas and say, what is this functional group? Which one is the functional group of being a ketone? You should be able to pick out those. Or I might say, which one is polar, which one's non-polar. You should be able to do that, okay, with your little flashcards. But I won't ask you to draw them. But this is just showing you, again, a ketone would be surrounded by, it's in the middle of the carbon skeleton, whereas an aldehyde is found at the end of a carbon skeleton. So how do you call these, what names? Like I said before, if it ends with OSE, it's a carbohydrate or sugar. If it ends with ASE, it's a enzyme. Okay? For example, sucrase is an enzyme that breaks up sucrose. One letter difference. Spelling counts. It has to. Okay? And if I can't read it, I've been grading your lab report. If I can't read what the number is, it's wrong. I don't know what it is. I can't guess. Okay? You've got to make it legible. So naming carbons and sugars, okay? There's 6 carbons there. And they have numbers to them. Starting with the aldehyde, or the end of it, that would be carbon 1, all the way to carbon 6. The thing that most students get mixed up on, I think you agree too, that it's a ring over here, and students tend to think that each one of these it's 6, like a stop sign, right? So you have these 6 carbons all around here, but it's not 6 carbons. Look at it closely. It's 5 carbons, and there's another carbon that comes out like a flag. But most students think the carbons is what makes up the ring. No, carbons, and then there's usually a oxygen there. So just beware of that. So we give them names. All right. Again, I'm not going to ask you to draw these out. I'm putting this 1 through 6 over here because something later on we're going to be dealing with when we have to make a duplicate copy of our DNA. I'm going to be using words like 5' and 3'. And that's where I just want to make sure you understand where I'm getting that from. When I say 5' or 3', we're talking about carbon number 5 for 5' or carbon number 3 for 3'. So when we get there, it'll make sense to you. So we could abbreviate it like that. Okay? So it's really a ring, and I usually see there's like a little flag that goes up there. So now you understand what they're made up of. You know that they're rings. If they're just one ring, we call it a monosaccharide. Okay? Mono means one. And they could either be glucose, galactose, or fructose. Glucose is our sugar that comes from wheat and stuff like that, grains, rice. Galactose is our monosaccharide from milk, and fructose is our monosaccharide from fruit. One other thing about fructose, it's not I want to say 6 carbon ring, but a 6-sided ring. It's a 5-sided ring. And that's pretty easy to know because fructose has the F and so does 5. And this is what they look like if you break them up into the linear area. Okay? We also have a disaccharide. And a disaccharide is 2 monosaccharides with a bond in between them. A covalent bond. But specifically, this one's called a glycosidic linkage. And basically, lactose, which is this, is made of 1 glucose molecule and 1 galactose molecule. When you drink milk, you are actually drinking lactose sugar. The thing is, lactose sugar can't be put into your body, or it can't get into, you can't absorb lactose because it's too big. So you have an enzyme called lactase. Good. And that lactase is going to break this up into smaller units, and those could get absorbed into your, well, not stomach, but in your intestines. Some people don't have that enzyme for whatever reason, lactase. These are people that are lactose intolerant. So what happens with them is that they drink milk products, cheese, butter, milk, okay? And they don't have the enzyme to break this up. So now this lactose sugar is going into your stomach, small intestines, large intestines. Eventually you'll poop it out. However, inside your large intestines, you have loads of bacteria there. Bacteria have the lactase, or I'm sorry, the lactase enzyme. Now look what's going to happen. They normally don't see a lot of lactose going into the large intestine because you have lactase enzyme that will break it up further up the line. But now a whole bolus of this lactose is going down into where the bacteria is, and they're going to party harder. They're going to be eating up all that. They can break down that lactose and start eating it up, and it's great. However, in the process of them breaking it up and letting them get energy there, they produce a lot of gas as a byproduct. And that gas, to you and I, if you have, I don't have lactose intolerance, but if you have it, you feel bloated because of all this excessive gas that the bacteria has just seen. And that's why they feel horrible. And they're left that kind of stuff, right? They'll bloat it and, oh, sorry, they feel horrible. So look, there's two ways, because it's not earth-shattering, you're not going to die from it. It can be miserable. But how do you think you could actually resolve this? Two ways. Go ahead. Right, you could take over the counter, you could take lactase tablets. After you know you want that ice cream, you take a couple of these tablets and it will break down the lactose for you before it gets down to the people who want to party on it. Or the other way is simply, don't eat milk products. Don't eat cheese and ice cream and all that. But that's what that is. All right? I'm off on a tangent a little bit, but you learned something, right? Okay. So that's what that is. All right? So, again, I don't want to bore you with this part, but basically, we've seen it before. Again, dehydration synthesis, hydrolysis over here. You're going to have, let's say, if this is two things over here, water is going to come out. We can make it over here. So it's two pieces here, two monosaccharides become one disaccharide, or we're going to break it. We're going to go from a disaccharide to two monosaccharides by way of an enzyme. Okay? So we did all that. So these are three important disaccharides you should know. Sucrose, table sugar, is made up of glucose and fructose. Lactose is sugar and milk, that's glucose and galactose. And maltose is our grain products, wheat, rice, that kind of stuff. And that's made up of two glucose molecules. You should know those. Okay? Polysaccharides. You've heard of this. These are potatoes. All right? Amongst other things. But polysaccharides are long chains and branches of these monosaccharides. Monosaccharide, mono. See, branches. Long chains and branches. Huge. Eating a potato is eating the same thing as a Twizzler candy. Well, what makes the two different? Well, Twizzlers are more like disaccharides or monosaccharides. And when they're in the smallest forms, they're very, very sweet. When they're in longer branches, they aren't sweet. Prove it. Bite into a raw potato. You tell me how sweet that is. Right? Okay? That's a polysaccharide. We have oligosaccharides. Again, oligo means short. And there's usually chains of like 3 or more monosaccharides. Polysaccharides are at least 50 monosaccharides. Okay? And like I said, the sweetness, polysaccharides are not sweet. Bite into a potato, and you tell me, but a Jolly Rancher is very sweet. So these are important polysaccharides you should know about. Okay? Hint, hint. Know these. Glycogen. We're going to talk about this later on too. This is the storage sugar in animals, including us. It's found in our liver and some muscle also. It's loaded with glucose. But it's just being stored there. Long chains and branches. Starch. This is storage sugars in plants. Now this is digestible in us. We can eat these things. Whether it's lettuce or celery, all right? We can eat those things. Potatoes, all right? We can eat those. And digestible. But we also have in plants cellulose. These are structural support in plants in what we call the cell walls. These are also polysaccharides, but they are not digestible by humans. However, they are still important in our diet because it's important in roughage and fiber to push things forward. I want to go into details about that, but that also helps prevent colon cancer and stuff. You need fiber in your diet to help your muscles in your intestines to push things along so it doesn't sit there long in case there's a cancer agent that's just going to sit there and cause cancer. You need things to push along. Some herbivores and termites, like cows, they do have cellulose digesting microbes. They can actually break down the cellulose. That's why we see a lot of cows eating grass and stuff. They could do that. They could break it up and use it for energy. We don't have that. And then we also have chitin, which is similar to cellulose but have nitrogen groups in it. And that's really the kind of exoskeletons in insects and bugs and things like that, in invertebrates. All right? They're also found in the cell walls of fungi. All right? So those are the ones you should know. And we do have classes here like nutrition that if you're really interested in this, you can go further and they'll talk more about this. Not that you want to keep hiking, but but you'll understand about what you can do with all these things and how it gets broken down. So just a summary, monosaccharide is one, disaccharide has 2 rings, a polysaccharide is long chains and branches.